Dear students, in this paper titled as Forensic Chemistry and Explosive, we shall be dealing with various topics like forensic chemistry, then beverages, examination of petroleum products and explosives. In the forensic chemistry, we shall be going through the various significant type of cases, exhibits, how the preliminary screening is done with the help of chemistry knowledge, the presumptive tests, the examination procedures involving the various standard methods and some instrumentation techniques and analysis. Then in the beverages topic, we shall try to know what are alcoholic and non-alcoholic beverages, the country made liquor, illicit liquor, medicinal preparations which also contain alcohol and drugs as constituents, the various drugs of abuse we shall study their classification, the drugs of abuse especially used in sports, then narcotic drugs, psychotropic substances, designer drugs and how to do their forensic examination, because before carrying out the examination you should know about the basic constituent, their types, their classification, then you will be more knowledgeable and you can deal with these in the forensic examination. Then we shall study about the various acts which will be helping you in the legal proceedings, that is the Drugs and Cosmetic Act, the Excise Act, NDPS Act and so on. In the examination of petroleum products, we shall first see what are petroleum products, how the distillation and fractionation is done, and we shall also be acquainted with the commercial uses of some of these fractions which are commercially used. Standard methods of analysis of petroleum products for adulteration we shall be knowing. Then we shall deal with the arson, that is the cases where fire is used. So, the chemistry of fire, you have to know investigation and evaluation of the various clue material that we will be getting from arson scenes, the analysis of arson exhibits by instrumental methods and how to manage the arson cases. And after that we shall study about the analysis of trace evidence, in which we shall deal about the cosmetics, dyes, the trap related evidence materials. And in the section of explosive, we shall become familiar with the classification, composition and characteristics of explosives, the pyrotechniques, the improvised explosive devices, explosion process and effects, the types of hazards and effect of blast wave on structures, human etc., with specific approach to scene of explosion, post blast residue collection, reconstruction of sequence of events and the evaluation and assessment of the scene of explosion. We shall be able to become familiar that how the systematic examination of explosive and explosion residues are done in laboratory using the chemical and instrumentation techniques, and how to interpret the results, and then what is the explosive act and deal with some case studies. So, dear student, this paper will give you idea about that how you can use your chemistry knowledge in dealing with the forensic cases. That is, as a forensic scientist, you should be very much familiar with all these, and for this is very important that you should try to understand the chemistry behind all these. So, let us begin with this module. Forensic science, as you are aware, in its broadest sense is the application of techniques and principles of all different sciences for the purpose of administration in the criminal justice system. So, dear students, in this first module, let us begin with the introduction to forensic chemistry. Forensic science, as you are aware, in its broadest sense is the application of techniques and principles of science for the purpose of administration in criminal justice system. And you already know science, you have so many branches, physics, chemistry, biology and so on, and in this paper we shall be dealing with the chemistry. So, chemistry is an integral part of forensic science, and forensic scientists must understand the principles and concepts and techniques of chemistry to perform their duties in an effective manner. Scientists of all types are often interested in the composition of a substance. However, the type of substance may vary according to their nature of work. Like pharmaceutical scientists identify the substance in a drug sample to set their expiry dates. Similarly, forensic scientists identify substance to connect suspects to crimes or to reconstruct a crime, that is, to determine how a crime has been committed. This area of science, that is forensic chemistry, is generally considered very fascinating and it continues to experience increasing popularity. The current trend of public interest in forensics is a direct result of various popular investigating programs on televisions that you also must have been watching. Crime investigation TV shows like CID in India and movies and various games on internet have brought forensic science into spotlight. Many of the tests demonstrated in these programs involve chemistry. Like you must have seen that they use substance to detect the presence of blood stains which otherwise could go unnoticed at the crime scene. That substance turns those spots into luminous stains. Obviously, you must be interested in knowing how to do all this, and that is what we will be studying in this entire paper. So, that magical looking substance is actually luminol, which reacts with blood to form a compound that glows when illuminated under the UV radiation in a dark room. In addition, the stories often show crime scene specialists bringing samples back to laboratory for examination in any one of the several large machines that seems to print out a report in just few seconds. But in reality, it is much more complicated than that. Chemists can analyze a substance in various ways in order to determine its composition, and after determining the composition of the substance, they can compare it with the already analyzed sample and come to know which is matching with the known sample. If they find a match between the sample obtained from the crime scene and the known sample, often called as control sample, they can identify the origin of the test sample collected from the crime scene. And this provides a very important clue in solving the case. Not only these television shows, but the media too has nowadays contributed a lot in the development of forensic science. The coverage of different criminal cases had brought the crime scene investigation and forensic analysis out of the labs and among the public. But being responsible forensic scientists, you should do it in a more scientific manner, and that is why the knowledge of the sciences which are associated, like in this paper we will be taking the help of chemistry, is very important, that you should know the basics and then try to solve and analyze these evidence and clues that you have obtained from the crime scene. So, as we move further, dear students, let us go back slightly in the history. The very first history of forensic chemistry began with analysis of poisons. In ancient times, there were evidences on the use of poisons by early Egyptians, Greeks and Romans. At that time, poisons were used both for murder and for execution of death penalty. The philosopher Socrates was sentenced to death by drinking hemlock. Before the development of any systematic scientific procedure of criminal investigation, circumstantial and hearsay evidence were usually employed to ascertain the guilt of any person. Arsenic, was a very commonly used poison during Roman times. The first instance of an actual chemical test for poison is the Blandy trial conducted during 1752. So, after going through a brief background that how chemistry or forensic chemistry was there in earlier times also, let us go to the definition of chemistry to revise, which are already familiar. Chemistry is nothing but it is the branch of science that deals with the study of composition of matter and the different changes that it undergoes. If we extend this to forensic, that is the forensic chemistry. Forensic chemistry is a specialized subfield of forensic science involving the application of techniques and principles of chemistry to the field of forensic investigation. It involves complex procedures of chemical analysis that are used to identify elements and compounds. Identification procedures are highly reliable and are frequently based on the physical as well as the chemical properties of these substances and is often supported by the data obtained from the analytical analysis. So, we can say that forensic chemistry is the application of principles of chemistry to law and criminal justice system. There are various analytical methods which may be used to find out the chemical changes that occur during any incident, and in this way it helps in the reconstruction of crime scenes. Forensic chemistry meets the need of both the scientific as well as the legal communities by innovation in its research, practice and presentation. Every facet of the criminal justice system would suffer without forensic chemistry. Forensic chemistry acts as armed force in the pursuit of justice. Forensic chemistry gives voice to the silent witness of physical evidence, and it plays a very critical role in the administration of justice. It not only aids in the investigation and prosecution of crimes, but also assists in meeting up the ends of justice. With this introduction and knowing the details about the forensic chemistry, let us see what are the roles of you as a forensic chemist. The ability of forensic professionals to establish the presence of a link between accused and crime by matching physical evidence collected from the scene of crime and those which are obtained from the victim or accused, that is, the principle is law of comparison, strengthen the case of prosecution. Forensic chemists perform different analysis to identify materials in order to determine the nature and composition of such evidence. A highly trained forensic chemist is capable of determining the composition and nature of materials and hence predicting the source as well as matching evidences collected from the crime scene with the control sample. Modern chemistry employs the traditional analytical methods or techniques hand in hand with the much younger methods of analysis, which are very fast as compared to the older methods. When we talk about the physical evidence collected from the scene of crime is properly collected, packaged and sealed in special containers in order to maintain its integrity and to prevent contamination. A chain of custody should be maintained for each evidence which is sent to the forensic laboratory for examination. This is very important. And at the laboratory, the evidence is then examined by trained personnel to reach up to a definite opinion. And yes, you can be one of these trained personnel. Forensic chemists have a crucial role in forensic science laboratories, and when required, they are often called on the courts to provide the testimony as expert witnesses. In these cases, the chemist may compare the questioned evidence to the controlled samples and may be asked to give an expert opinion in court on the basis of grounds on which such opinion is based. Their academic credentials, along with years of experience to deal with such analysis, render their opinion more valuable and reliable. The fact that most of the samples that are submitted for analysis are contaminated with dirt or debris and several other contaminants, this poses a major challenge before the forensic chemist. Every substance that is collected from the scene of crime has a unique composition that can ultimately be identified by the chemistry knowledge. Arsonists, for example, often use accelerants like kerosene or gasoline to accelerate the rate of combustion, and each accelerant has its unique composition. And a forensic chemist may search for and collect burnt and unburnt material samples, extract the volatile hydrocarbons from them, and may use gas chromatography like techniques to separate these components and then analyze. So, as a forensic chemist, one can clearly say that which precise accelerant was used at the crime scene of fire to create that fire or to enhance the rate of combustion. So, dear students, so all you can be now so much confident that after going through this paper and knowing the various chemistry background and how the various instrumental method of analysis are to be done, you will be more comfortable in dealing with these type of cases. So, dear students, let us understand more about forensic chemistry, its scopes and significance, etc., with the help of graphics and visuals.
Moving on to history. The very first history of forensic chemistry began with analysis of poisons. In ancient times, there were evidences of the use of poisons by early Egyptians, Greeks, and Romans. At that time, poisons were used both for murder and for the execution of death penalty. The philosopher Socrates was sentenced to death by drinking hemlock. Before the development of any systematic scientific procedure of criminal investigation, circumstantial and hearsay evidence were usually employed to ascertain the guilt of any person. Arsenic was a commonly used poison during Roman times. The first instance of an actual chemical test for poison is the Blandy trial conducted during 1752. Now, moving on to definition. Chemistry is the branch of science that deals with the study of the composition of matter and different changes that it undergoes. Forensic chemistry is a specialized subfield of forensic science involving the application of techniques and principles of chemistry to the field of forensic investigation. It involves complex procedures of chemical analysis that are used to identify elements and compounds. Identification procedures are highly reliable and are frequently based on the physical and chemical properties of the substance, supported by the data obtained from analytical analysis. Forensic chemistry is the application of principles of chemistry to law and the criminal justice system. There are various analytical methods which may be used to find out the chemical changes that occurred during any incident, and in this way it helps in the reconstruction of crime scene. Forensic chemistry meets the need of both the scientific and the legal communities by innovations in its research, practice, and presentation. Every facet of the criminal justice system would suffer without forensic chemistry. Forensic chemistry acts as armed force in the pursuit of justice. Forensic chemistry gives voice to the silent witness of physical evidence. It plays a critical role in the administration of justice. It not only aids in the investigation and prosecution of crimes, but also assists in meeting up the ends of justice. Role of a forensic chemist: the ability of forensic professionals to establish the presence of a link between accused and crime by matching physical evidence collected from the scene of crime and those which are obtained from the victim or accused, that is, law of comparison, to strengthen the case of prosecution. Forensic chemists perform different analysis to identify materials in order to determine the nature and composition of such evidence. A highly trained forensic chemist is capable of determining the composition and nature of materials and predicting the source, as well as matching evidences collected from the crime scene with the control sample. Modern chemistry employs the traditional analytical techniques hand in hand with much younger methods of analysis. Physical evidence collected from the scene of crime is properly collected, packaged, and sealed in special containers in order to maintain its integrity and to prevent contamination. A chain of custody should be maintained for each evidence which is sent to forensic laboratory for examination. At the laboratory, the evidence is examined by trained personnel to reach up to a definite opinion. Forensic chemists have a crucial role in forensic science laboratories, and when required, they are often called on in the courts to provide testimony as expert witnesses. In these cases, the chemist may compare questioned evidence to controlled samples and may be asked to give an expert opinion in court on the basis of grounds on which such opinion is based. Their academic credentials, along with years of experience to deal with such analysis, render their opinion valuable and believable. The fact that most samples that are submitted for analysis are contaminated with dirt or debris and several other contaminants. This poses a major challenge before forensic chemists. Every substance that is collected from the scene of crime has a unique composition that can ultimately be identified. Arsonists, for example, often use accelerants such as kerosene or gasoline to accelerate the rate of combustion, and each accelerant has its own unique composition. A forensic chemist may search for and collect burnt and unburnt material samples, extract the volatile hydrocarbons from them, and may use gas chromatography to separate the components of these samples. Scope and significance in forensic chemistry. The principles of chemistry play quite a crucial role in each division of forensic science laboratory. A few of them are as follows: examination of metal alloys and metal fragments for identification and comparison, examination of petroleum products like diesel, petrol, and kerosene, analysis of dyes, paints, inks, fillers, binders, and various other chemicals to ascertain their identity, composition, quality, as well as quantity, examination of low standard construction materials like cement, bricks, etc., as well as the adulteration in these building materials, analysis of various narcotics, designer and abused drugs like bhang, opium, ganja, LSD, etc., as well as illicit liquors, determination of alcohol in blood and urine in cases of suspected drunkenness, and analysis of fermented wash, varnish, etc. in prohibition and excise cases, analysis of pesticides for their identification, examination of inflammable material in suspected cases of arson, dowry debts, etc. And lastly, analysis of explosives, firearms, and ammunition. Now, moving on to techniques commonly employed in forensic chemistry. Forensic chemistry deals with both organic and inorganic analysis. Each method of analysis is used in concert with specialized techniques and instrumentation. The process may range from simple ones like conducting a chemical test or comparing the density of evidence like soil samples to the complicated ones like using a neutron activation analysis or mass spectrometer to characterize an unknown substance. A vast range of analytical techniques are generally employed in forensic analysis. These include ultraviolet, visible, and infrared spectrophotometry (GCMS), high pressure liquid chromatography, neutron activation analysis, and atomic absorption spectrophotometry. The choice of technique and instrument to be used depends on the type of sample to be analyzed. Now, let us know about each of these techniques. Gas chromatography. Gas chromatography, or GC, separates volatile substances into different components by passing the volatile materials through a long absorbent column. The technique is highly reproducible and reliable since each sample is likely to contain a definite number and type of impurities. It may provide a close match of the unknown accelerant to a known source, such as a gasoline tank or hardware store. It may be necessary to vaporize a tiny sample of the material to provide volatile gases for analysis. The components of the vapor are then passed through the column and separated into a number of components, each of which can be captured and analyzed. In most cases, the accelerant will be mixed with portions of burnt paint or building material so as to make its identification quite impossible. But the ability of the GC to separate tiny portions helps in identification. The GC is often connected to a mass spectrometer. Mass spectrometry, or MS, breaks samples apart and separates the ionized fragments by mass and charge. Vast libraries of comparison fragments make computer-aided identification of materials possible even when the sample is very small. Most forensic laboratories have access to a combined gas chromatograph or mass spectrometer, or GC or MS. High pressure liquid chromatography, or HPLC, separates many types of drugs and may also be combined with MS. Now we will learn about spectrophotometry. Analysts may use several types of spectrophotometry. A typical spectrophotometer consists of a light source that provides light of unknown wavelength, a holder to a position solid, liquid, or gaseous samples, and a system of lenses and photocells that compare light shining on the sample with light passing through. A decrease in the intensity of light passing through the substance indicates the presence of materials that absorbs light at that wavelength. The absorbance is quantitative and a measure of the concentration of material, and the wavelengths of maximum absorbance are characteristic of the type of material. Infrared spectrophotometry is especially useful for the identification of organic compounds, as bonds between certain atoms readily absorb infrared radiation, or IR. Next, we will discuss about nuclear magnetic resonance spectrophotometry. Nuclear magnetic resonance spectrophotometry, or NMR, makes use of the fact that nuclei of some molecules absorb radiofrequency radiation in strong magnetic fields. Nuclei in certain molecules absorb radiation at characteristic frequencies, making the identification of even tiny or impure samples possible. X-ray analysis allows the forensic investigator to visualize foreign objects within the body. Nuclear magnetic resonance spectroscopy is a powerful analytical technique used to characterize organic molecules by identifying carbon-hydrogen frameworks within molecules. Two common types of NMR spectroscopy are used to characterize organic structure. Hydrogen NMR is used to determine the type and number of H atoms in a molecule. carbon NMR is used to determine the type of carbon atoms in the molecule. The source of energy in NMR is radio waves, which have long wavelengths and thus low energy and frequency. When low energy radio waves interact with the molecule, they can change the nuclear spins of some elements, including hydrogen and carbon. When a charged particle, such as a proton, spins on its axis, it creates a magnetic field. Thus, the nucleus can be considered to be a tiny bar magnet. Normally, these tiny bar magnets are randomly oriented in space. However, in the presence of a magnetic field V0, they are oriented with or against this applied field. More nuclei are oriented with the applied field because this arrangement is lower in energy. The energy difference between these two states is very small, that is, less than 0.1 calories. In a magnetic field, there are now two energy states for a proton, a lower energy state with the nucleus aligned in the same direction as V0 and a higher energy state in which the nucleus aligned against V0. When an external energy source h nu that matches the energy difference dE between these two states is applied, energy is absorbed, causing the nucleus to spin flip from one orientation to another. The energy difference between these two nuclear spin states corresponds to the low frequency RF region of the electromagnetic spectrum. Thus, two variables characterize NMR: an applied magnetic field V0, the strength of which is measured in Tesla or capital T, and the frequency nu of radiation used for resonance, measured in Hertz or megahertz. The frequency needed for resonance and the applied magnetic field strength are proportionally related. So, the stronger the magnetic field, the larger the energy difference between the two nuclear spin states, and the higher the nu needed for resonance. NMR spectrometers are referred to as 300 MHz instruments, 500 MHz instruments, and so forth, depending on the frequency of the RF radiation used for resonance. These spectrometers use very powerful magnets to create a small but measurable energy difference between two possible spin states. Next technique is neutron activation analysis. In neutron activation analysis, a beam of neutrons from a nuclear reactor is directed at a sample of test material. The material becomes temporarily radioactive, emitting gamma rays that are characteristic of the composition. Analysis of the gamma radiation provides a highly accurate and reproducible determination of the content of the sample. This technique has made possible the determination of arsenic in the hair of corpses buried for hundreds of years. In one case, the body of an Arctic explorer who had died under suspicious circumstances during the 1870s was found buried in a coffin surrounded by ice. Neutron activation analysis of hair from the body showed that hair that was several centimeters long contained little arsenic, but that shorter hair closer to the scalp, which had grown in the few days before death, contained high levels of arsenic, indicating that death was probably caused by arsenic poisoning. Cases encountered in forensic chemistry. Forensic chemistry deals with the chemical analysis of a variety of physical evidences. These include samples of suspected accelerants from noxious chemicals, arson debris, propellants, lubricants, gunshot residues, etc. The cases that are typically examined include homicides, arsons, assaults, robberies, etc. A few of them are discussed here. First is arson investigation. Arsonists may use a number of accelerants to set a fire. During the examination of any arson scene and its background cause, investigators must look for the fire debris that they believe to contain residues of the accelerants used in arson. The debris is collected and packed in airtight containers to avoid loss of its volatile components and is then transported to forensic science laboratory for analysis. Gas chromatography, mass spectrometry is employed to identify and quantitatively analyze the traces of ignitable liquid residue in collected samples. Along with this, forensic chemists often concentrate on several other minute residue traces. They do this by using activated charcoal strips to adsorb the accelerant residues, which are then eluted off the strip by dissolving in a solvent. Next is gunshot residue. In addition to arson debris, the section also analyzes evidence associated with shooting cases. When ammunition is discharged from a weapon, gases are generated which contain burned and unburned components of primer and propellant cartridge, which may deposit on the hands and clothes of the person firing the weapon and is referred to as gunshot residue or GSR. Scanning electron microscope or SEM coupled with an energy dispersive spectrometer or EDS is used to examine tape lifts taken from the hands of suspected shooters. If elements like barium, antimony, and lead is found in the sample, it is classified as primer residue. Next are toxins. Forensic chemists examine a vast range of evidence such as blood stains, urine, etc., for traces of drugs or poisons. Many businesses, including sports, now require the drug screening of employees and sportspersons. It is the chief task of the forensic chemist to distinguish between the external addition of illegal drugs and metabolites from certain food materials like poppy seeds. Such tests may be as simple as various color tests or may involve different instrumental techniques ranging from simple to complex one. Paper or thin layer chromatography or complicated techniques like gas chromatography or electrophoresis could be used for the analysis of different toxins. In death cases, due to unknown cause, samples of the victim's blood, lungs, urine, stomach content, and vitreous humor are examined for traces of poisons. Insects, in some cases found on the dead bodies, are also examined, as they may absorb drug or poison from the body in trace amounts, which sometimes are found long after, even when their concentrations in the body have reduced substantially. Next are the noxious chemicals. Noxious chemicals like caspicine, spray, and tear gas can be both qualitatively as well as quantitatively analyzed by using the gas chromatograph mass spectrometer or GCMS. Tear gas is a component in dye packs that are used by banks to identify the suspect, as they may be found on the clothing of the person involved after the dye pack has exploded. And lastly, miscellaneous analysis. The forensic chemistry can also assist in investigation of sexual assault cases by examining the lubricants, even when present in traces used by suspects in rape cases.
So dear students, let us summarize what we have learned in this module. We have learned that chemistry is an integral part of forensic science, and forensic scientists must understand the principles, concepts and techniques of chemistry to perform their duties in an effective manner. The very first history of forensic chemistry began with analysis of poisons. So, with this we have glanced through the some historical perspective of forensic chemistry. Forensic chemistry is the application of principles of chemistry to law and the criminal justice system in its precise definition, you can say. Forensic chemists, if we look at their roles, they analyze the materials to determine their nature and they try to establish a link between crime, criminal and victim, and thus helping solve the case. Forensic chemistry has vast application including analysis of dyes, paints, inks, fillers, binders, various other chemicals to ascertain their identity, composition, quality as well as quantity. Forensic chemistry incorporates both organic and inorganic analysis. Each method of analysis uses specialized techniques and instrumentation, and we shall be learning more about this in detail in the subsequent modules. Thank you.